Cobalt has a very interesting and diverse properties, right? Which makes it a very sought after material in a number of industries, right? Ranging from commercial, right? Industrial, military, to even medical, right? And aerospace. Now, the first interesting property of cobalt, right, is known as ferromagnetic, right? Basically meaning that with the material made out of cobalt, right, you can actually produce a magnet. Now, this property, right, is particularly used, right, when making magnetic alloys, right? When we speak of a magnetic alloy, right, we speak of a combination of steel and cobalt that produces a magnetic effect on the material, right? Now, with cobalt, you can produce hard, permanent magnets, right? When we look at one type of magnet, right, which is produced using cobalt, right, is known as alnico, right? Basically, alnico is a combination of aluminium, nickel, right, and cobalt, right, which produces a magnet, which is known as alnico, right? This alnico magnet is quite hard, right? It is a permanent magnet, right? And it has high cohesivity, right, throughout the area, or yes, the area of the magnet. This particular magnet is used in motors, right? In generators and hard disk drives, right? And in sensors. When we zoom into specifically the mechanical properties of cobalt, right? In products like super alloys, right? And high speed steel alloys, right? Cobalt performs a very important role in these applications, but particularly it is of a mechanical nature, right? These type of properties are hardness, right? If you add cobalt to a material, it tends to make the material hard, right? It is and it has a quality of brittleness to it, right? It is of a high strength quality, right? So if you add cobalt into these two types of products that I've mentioned, you can achieve, right, high strength, right? And you can achieve anti-wear properties in high temperature, right? So it performs well in high temperature too, right? And when we look at cobalt, right, it has a very high melting point, right? So it can perform very well under a very high temperature or a very high temperature environment. When we look deep into the first type of product, right, which is the super alloys, right? The cobalt-based super alloys, right? They are particularly used in environments where um, you need to have some sort of anti-corrosion qualities in a high temperature environment, right? And you need to be able to maintain the integrity of the steel alloy, the super alloy, right? Under very high temperatures, right? And very hostile temperatures. So mostly copper-based super alloys, right, are used in the space industry, right? In things like gas turbines, right, which are fundamentally, yes, gas turbines under high temperatures. They're also used in gas engines, right? They are also used in space vehicles, right? And they are also used as in engines, aircraft engines, for example, planes and rockets, right? And things like that. When we look at the second type of products that cobalt is used in, right, it is known as high speed steel alloys, right? But they are known as copper based high speed steel alloys, right? Basically, you find two types of these types of copper-based alloys, right? One is known as M35, right, and the other is known as M42. These are the most two commonly used copper-based high-speed um, steel alloys, which are used, um, which cobalt is used in, right? Particularly this material, right, is used in cutting tools, right? When you are cutting and shaping materials, right, or parts for a car or plane and whatever, right? Cobalt is used in high-speed steels under those conditions, right? Or a rotating turbine, right? Something that rotates in high speed. It uses copper-based high-speed steel alloys. Cobalt is also a great catalyst, right? It can promote reaction of certain things. For example, it is particularly used as a catalyst in the petroleum industry, right? The oil and gas industry, to basically remove sulfur from these petroleum products. The products can range from jet fuel, right? Normal petrol, right? You can also remove sulfur from natural gas, right? So it is a good catalyst that is used in the desulfurization process, particularly in the oil and gas and petroleum industry. Cobalt also increases the weldability of these two products that I've just mentioned, right? It is also a excellent, right, resistant on hot corrosion, right? It is also excellent to deal with thermal fatigue. Now, when focused on the medical use of cobalt, right, when cobalt is used in the medical industry, right, it is particularly used to generate radioactivity, right? Now, cobalt 60 is the isotope which is used to produce various radiation, right, ranging from gamma waves, right? It can also emit beta waves. These two type of waves are particularly used in treatments of tumors, right? And particularly brain tumors, right? And cancer, right? But you can use it for any part of the body or any type of tumor or any type of cancer, yes, tumor that you can find. When we look at the traditional historic use of cobalt, right, it was fundamentally used as a pigment, right, or a colorant. Cobalt traditionally was known as cobalt blue, referring to the blue color or the blue colorant, right, or dye nature of cobalt. It was particularly used to decorate ceramics, right, things like porcelain, right. It was used in ink, right. It was also used added to things like glass, right, to particularly taint the color of glass to blue. So traditionally it was used as a pigment and a dye. Yes, paint, right? It was also added in paint to change the color of the paint to blue. And cobalt is used in the electrical and electronic industries, right? Particularly, it is used as a battery material, right? So cobalt is used in rechargeable batteries, which we found in a number of portable devices, right? Which range from cell phones, right? Laptops, iPads, right? And cobalt is also used in the electrical vehicle market and industries, right? So cobalt is quite central to the transition from fossil fuel based cars and equipment, right, to electrical based equipment. So it is an important battery material. It is particularly used as a cathode technology, right, in rechargeable batteries.